Multiplicative groups. A set of elements forms a group with respect to multiplication modulo n. Let us check. The set S1 is equal to 1, 2, 3, 4. A group with respect to multiplication modulo five. With respect to multiplication modulo 5. Okay, let us consider the Cayley table. Consider the Cayley table with operation is binary operation is multiplication 1, 2, 3, 4. 1, 2, 3, 4. Here 1, 1 into 1 into 2 mod 5, it is 2, 1 into 3 mod 5, 3, 1 into 4 mod 5, 4, 2 into 1 mod 5, 2, 2 into 2 mod 5, 2, sorry, 4, 2 into 3 mod 5, it is 1, 2 into 4, 8 mod 5, 3, then 3 into 1, it is 3, 3 into 2 mod 5, it is 6, it is 1, 3 into 3, it is 9, it is 4, mod 5 is 4, 3 into 4, 12, 12 mod 5 is 2, then 4 mod 5 is 4, 4 mod 2 is 3, 4 into 2, 8 mod 5 is 3, 4 into 3, 12, 12 mod 5 is equal to 2, then 4 into 4, it is 1. Okay, here it is, the operation is closed, multiplication it is closed. Then, so closure property, it is satisfied. Then we know multiplication is associative, so that property is okay. Then identity element, existence of identity, that is if A is an element of the set, A into E is equal to A. Okay, here you can see 1 is the identity element, 1 is the identity element. So this associative, this identity element exists in inverse, existence of inverse for each element. You can see inverse of 1 is 1, then inverse of 2 is 3, that is 2 into 3 mod 5, it is the identity element 1. Then here you can see 3 into 2 mod 5 is equal to 1, so the identity element. So inverse of 3 is 2, inverse of 2 is 3, then inverse of 4, it is 4 itself. 4 into 4 mod 5 is equal to identity element. So for every element, inverse also exists. So this is a group, this forms a group. The set 1, 2, 3, 4 forms a group. Let us consider another one. S2 equal to 3, 6, 9, 12. Is a group with respect to multiplication modulo 15. Okay, consider the Cayley table. All the resultant elements are the members of the set. All the resultant elements are the members of the set. So this is closed. So closure property, it is satisfied. Then associativity, okay, since multiplication is associative, this property also satisfied. Then the identity element. See what is the identity element? 6 into 3, it is 3. 6 into 6, it is 6. 6 into 9, it is 9. 6 into 12, it is 12. So this 6 is the identity element. So in a multiplicative group, it is not necessary that identity element is equal to 1 always. Okay, here you can see the identity element is 6. Okay, here you can see the inverse. 3 into 12, it is 6. 36 more 15, it is 6, the identity element. And you can see 6 into 6, 36 more 15 is equal to 6, the identity element. Then here you can see 9 into 9, 81. 81 more 15 is equal to 6, the identity element. Then you can see 12 into 3, 36 more 15 is equal to the identity element. Okay. So inverse exists for each element. The identity element is 6, associativity okay, closure property okay, inverse also exists okay. So this is a group under multiplication modulo 15. Here you have to note that identity element is 6 here. So it is not necessary that E is equal to 1 always. It is not necessary that E equal to 1, that is the identity element is equal to 1 always. Okay. So there are many ways, many theorems to construct a multiplicative group. Let us do one thing. Let us consider set 10 which is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the residue set, all the elements less than 10 and greater than or equal to 0. Let us construct a set so that if A is a member, A belongs to set 10 and GCD of A and 10 is equal to 1. We will select such elements, okay. Then we will get a group 1, 3, 7 and 9. Okay, let us call it set 10 star. In general, set 10 star, it is a set of elements. It is a set of elements. If A belongs to this set, set star, A will be a member of set n such that GCD of A comma n is equal to 1. That is A and n are co-prime. So all the elements from set n where A is co-prime to n, such elements will form a set. That set is called set n star. Okay, let us check this set form a group under multiplication modulo 10 is a group under multiplication modulo 10. Our question is set 10 star a group under where with respect to multiplication modulo 10. Let us form the KL table. We know set star 10 is equal to 1, 3, 7, 9. KL table 10, 9 into 7, it is 63 more 10, it is 3, then 9 into 9, it is 1. Okay, here the operation is closed, that is all the resultant elements, all the members of the set, so the operation is closed. Then multiplication is associative, then which is identity element. What is the identity element? Here you can see 1 is the identity element, E is equal to 1. 1 is the identity element and the inverse, existence of inverse. What are the inverse of 1? It is 1. Then inverse of 3, it is 7. Inverse of 7, it is 3. Inverse of 9, it is 9 is okay. So for all elements inverse exists. So this is a group. Is this an abelian group? Yes, this is an abelian group because multiplication is commutative. A into B equal to B into A. So this is a, we can say this is an abelian group. Okay, let us think about some big values of En. Okay, find the inverse of 13 mod 29. That is finding the inverse element of 13 in modulo 29 system. That is 13 into some element x should be equal to 1 mod 29. Okay, we have to find this x, and here is inverse exists for A mod n if and only if GCD of A comma n equal to 1. Let us check what are the GCD of 13 and 29. 29, 13, then 2, 26, 3, that is we can write 29 equal to 13 into 2 plus 3, and next stage 4 into 3, it is 12, 1. Okay, GCD equal to 1. We can write this as 13 equal to 3 into 4 times plus 1. Okay, then we know the Lafontaine equation GCD of a comma b equal to ax plus b. A and b are positive integers, x plus by. A and b are positive integers, x and y are any two integers. And if we are able to write GCD of a comma b like this, then x is the inverse of a. Okay, let us try to do the backward replacement. We can write from this equation, we can write 1 equal to 13 minus 4, and from this equation we can write 3 equal to 29 minus 13 into 2. Okay, so we will be replacing this 3. So this equal to 13 minus 3 will be replaced. We are replacing this 3 with 29 minus 13 into 2, and here we have 4. Let us expand this. 13 minus 29 into 4 minus into minus, that is plus, 13 into 4 into 2, 8, and this is equal to 13 and 8, 13, so total 13 into 9 plus 29 into minus 4. This is the form ax plus by. Here we can see 9 is the inverse of 13 in mode 29 system. Okay, let us check it. We should get 13 into 9 mod 29 is equal to 1. Okay, 13 into 9 is 7, 117. Okay, 117 mod 29, 117 29 before 6, 3, 11. Okay, that is 1. This is equal to 1. So 9 is the inverse of 9 mod 29 is the inverse of 13 mod 29. We are using extended Euclid algorithm to find the inverse element, to find the inverse of an element in modern system. Here we used extended Euclid algorithm. Find the multiplicative inverse of 53 in modulo 123 system. This multiplicative inverse exists if and only if the GCD of 53 and 123 equal to 1. 53 is our A and 120 is our B. Okay, let us check this. 123 divided by 53. So it is 2, 6, 10, 17, then 53, 2, well, let's try 3, 1, 5, 2. Okay, from this we can write 123 equal to 53 into 2 plus 17. From this we can write 53 is equal to 17 into 3 plus 2 and 17, it is 8, 16, 1. So GCD is equal to 1. So we can see GCD is equal to 1. So this is correct. Okay, and from this we can write 17 equal to 2 into 8 plus 1. Okay, we are applying extended Euclid algorithm. We are applying extended Euclid algorithm to find this inverse. We know GCD of a comma b can be represented as ax plus by, and here this x is the multiplicative inverse of a. Okay, let us try to write GCD of 53 comma 123 in this form. That is, from this equation we will get from this one we will get 1 equal to 17 minus 2 into 8. Okay, let us take a new page. 1 equal to 17 minus 2 into 8, and from this equation we will get 2 equal to 53 minus 17 into 3. So we will replace this 2 as 3 minus 17 into 3. This is our 2 into 8 is equal to 17 minus. Okay, so if we expand this bracket, we will be getting 17 minus 53. Okay, 53 into 8 plus 17 into 24. That is 17 into 25. 25 minus 53 into 8. That is what we are getting from this. Okay, next we will replace this 17. Okay, 17 by 123 minus 53 into 2. This 17 is equal to 123 minus 53 into 2. This is our 17. 25 is here, then minus 53 into 8. If we expand this bracket, we will be getting 123 into 25 minus 53 into 25 into 2, 50, minus 53 into 8. Okay, this will be equal to C. Our A is 53, B is 123. A is 53, B is 123. So 1 is our GCD. So this is our GCD. So our X equal to minus 58 and Y equal to 25. We have set X is the multiplicative inverse of A, that is our A is 53. Okay, so minus 58 is the multiplicative inverse of 53. Okay, let us check what is minus 58 in what is the value of minus 58 in modulo 123 system. We know the modulo n of a negative number is n minus, that is 123 minus absolute value of minus 58 mod 123, that is equal to 123 minus 58. We are getting 65. Okay, that is 53 into 65 modulo 123 is equal to 1. Okay, let us check it. What is it? Is 3445 mod 123 is equal to 1. 3445 mod 123 is equal to 1. So 65, so 65 mod 123 is the multiplicative inverse of 53 modulo 123.